All right, so we are going to do the vectors and matrices question. This is taken from the most recent past paper. This is taken from the 2021 paper. And the vectors and matrices is a good question where we can attempt to score maximum marks. CXC hardly ever deviates from what they ask, and once we have a fair idea of how to answer the question, it should give us an opportunity to get some actual marks in this question. All right. Calculate the product of those two matrices. Before we attempt to work out the product, we need to ensure these two matrices are what we call conformable for multiplication. Conformable means that the two matrices can be multiplied. So here we have a 2 by 2. And here we have, this is row by column. This is row by column. We have 2 rows and 3 columns. As long as these two numbers are the same, the matrices can be multiplied. So we will form a 2 by 3. What this means, and they ask for you to state why the matrices are conformable. Well, the number of columns of the first matrix is equal to the number of rows of the second matrix. So once we do that, we know we find in a 2 by 3. That is our end result. So we are multiplying first row by first column. We can do a bracket and we know it's a 2 by 3. So the first element, 5 by 2. 5 multiplied by 2 will give me 10 plus 5 by 0, which is 0. So that is first row, first column. So the first row by the first column, 5 by 2, and then 5 by 0, right? 5 by 2 and then 4 by 0. So this is row 1 by column 1, column 2, column 3. So this is row 1, column 1. So the next one, the next element, row 1 by column 2. So we multiply 5 by 1, 5 by 1 now, plus 4 by 3. So we are finished with row 1, column 2. So we go into row 1, column 3 now. So 5 by 4, so it's the first element by the first element. The first element here by the first element, the second element by the second element. So 5 by negative 4 plus 4 by 4. Now, I'm going to stop there and I want you to multiply row 2 by column 1, row 2 by column 2, and row 2 by column 3. So you try it, and we multiply corresponding elements. First element with first element. Second element with second element. So try it. All right, are you all finished? Nicole and Bridget, are you all finished?
Yeah, miss.
All right, let's see what you have. So now we're doing the second row, first column. So first element, second element, second element. So minus 3 by 2 plus minus 2 by 0. Right? Then we have minus 3 by 1 and minus 2 by 0. Then we have minus 3 by minus 4 and minus 2 by 6. So let me try and simplify. 10 plus 0 is 10. 5 by 1 is 5 plus 12. So far we have 10, 17. This is minus 20 plus 5 by 4 plus 4 by 6. This was 4 by 6. So this is 4. Then minus 6 plus 0, minus 6, minus 3 by minus 3. So this is minus 9. And then 12 minus 12, 0. Did you all get that? Or anything close to that?
Miss, I got something close to it, but it's okay if I take it out.
Yes, yes, go ahead. Nicole, what about you? What do you have?
Miss, I wrote for the second row minus 6, I put 0.
Oh, all right.
Yes.
So you make a note of that change, right?
Finish, Miss.
All right, you finished? Bridget, you still writing?
No, miss, I finished.
Okay, let's go. Find the inverse. So to find the inverse, we need to find the determinant. So the determinant, if A is A, B, C, D, then the determinant of A is A by D minus B by C. So I want you to do it. 5, 4, negative 3, negative 2. So the determinant of A across opposite ends of the diagonal. Are you all finished?
Yeah, miss.
So 5 multiplied by -2 is -10. Take away 4 multiplied by -3. So this will give us -12, which is -10 plus 12, which is 2. So the determinant is 2. The inverse now is 1 over the determinant, and you switch the places of D and A, and you take the negative of B and C. So using this, find A inverse. Switch the places of A and B and change the sign of B and C. So it's 1 over 2. You fill in what's supposed to be there.
Finish, miss.
All right, so you're supposed to have -2, 5, -4, 3. Do you have that?
Yeah, miss.
Yeah, miss.
All right. This one, let me erase the answer. Now, we just need to understand the vectors and matrices, because CXC hardly ever deviates from this question. So this one has been the same since I don't know how long. So let's see what they ask in the question. The diagram below shows a triangle, AOB. So we can see that triangle. OA is R, so we know that. And OB is S. So we see those, right? In addition, E is the midpoint of CD, right? And OC is 3/4 OA. So if OC is 3/4 OA, therefore this part here is a quarter, because 3/4 plus a quarter will give us a half. You all understand that?
Yeah.
Yeah.
AD is 2/3. So how much would BD be? If here is 2/3, how much again to make a whole? 2/3 plus how much? 1/3. So that is some information we can put in our diagram. They are asking us for CD. So they want the vector CD. So we look at the route. We're going from C to D. But we cannot go, so we have to use the triangle law of vectors. So the other two vectors that will take us from point C to point D is if we travel through A. So it's like you are going from point C to point D, but you cannot walk straight across. You have to find an alternate route. So therefore, you will go from C to A, and then from A to D. Do you all see that?
Yes, miss.
So CA plus AD. And when we write in vectors, this C is always my start, D is always my end, and whatever I put in the middle here must be the same. That is the common point. Are you all with me so far?
Yeah, miss.
So, let's know it. Right. So, a quarter of R, because the whole vector OA is R, so a quarter of R plus AD. AD is 2/3 AB. So we need to find, so it's 2/3 of AB. So we need to find the vector AB because that wasn't given. So watch this. We're going from point A to point B. So we will travel to O and then we will travel to B. But if we go from A to O, the vector must change the sign. It is like you are walking forward, now you're walking backward. So this would be 2/3 minus R plus S. So a quarter R minus 2/3 R plus 2/3 S. So work out for me a quarter minus 2/3. How much is that? A quarter minus 2/3. How much is a quarter minus 2/3? Use the calculator.
Miss 512. Minus 5.
Minus 5/12. R plus 2/3 S. Do you all understand how I got that?
Yes, miss.
All right, so take it out. Let me know when you all are finished writing.
I finished, miss.
Bridget, you finished as well?
Miss, I know I finished.
Oh, Nicole, you
Yeah,
finished?
miss.
All
Yes,
right.
miss.
Sorry. Now watch this. We need to understand what's going on here. They ask us to find OE. So let me draw a line from O to E. What is the shortest possible distance that I must travel to go from O to E? We know my start vector must be O, and we know my end vector must be E. So what point must I pass through? Nicole or Bridget, I want to go from this point to this point. How will I travel? From O to?
O to C to E, miss?
Yes, O to C, and then from C to E. So O to C and then C to E. The vector OC is 3/4 R. The vector CE is a half. Remember, E is the midpoint, so it is a half this vector that we found, because this said that E is the midpoint of CD. So plus a half minus 5/12 R plus 2/3 S. So work out for me, what is a half of minus 5/12? A half multiplied by negative 5/12.
Negative 5/24.
Yes. Negative 5/24 R. And how much is a half multiplied by 2/3?
1/3.
Yes, 1/3 S. Now simplify this for me. 3/4 take away 5/24. Three-quarter minus 5/24.
That's 13/24.
Just 13/24. 13/24 R plus 1/3 S. That is my answer. So you all feel free to take it out. Finish?
Yes, miss.
Right. Bridget, are you finished as well?
Miss, I just now answer.
Oh, Nicole, are you finished?
Yeah, miss.
All right. Let's go. What are the coordinates of R? What is the X value and what is the Y value of R? This is the point R here. What are the coordinates? What is the X value and what is the Y? X is how much?
-1.
Right? So if we have to write it as a row, as a column, -1, and what is Y? 4. So that wasn't too bad, right? -1, 4. That is the answer. They ask us to determine QR. They want the length of QR. So let's go back. We have to find the vector QR. So to go from, watch it, we're going from Q to R. Which vectors must we add to go from Q to R? Q to R will be what? I'm starting at Q and I want to end at R. So QR will be what two vectors?
5 to -1.
No, what are the vectors in terms of O? If I start at Q, where must I pass to reach R? Which route must I take to reach R? If you start walking at Q, Bridget, and you want to reach R, where must the triangle travel?
Q had to go down to 0.
You have to go from Q to 0, Q to O.
To
So
R.
QR, you're going from QO and then from O to R. You see that? Watch. We're going from Q to O and then O to R. Want to see that? Do you all see that is the direction we must go to reach R?
Yes, yeah, miss.
Right. Now, what is the vector? What is this coordinate here for Q? What is the point? 5 what?
50.
No. 5 is the X. What is the Y? 2. So this would be negative, because if we go from O to Q, it's positive 5, 2. So this will be negative 5, 2. And the vector OR, we just worked out that was negative 1, 4. So work out this for me. Negative 5, negative 1, negative 2 plus 4. Work out that for me and tell me what you get.
Minus 6, 2.
Minus 6, 2. Bridget, you can confirm that? Bridget, you can confirm that answer?
Yes, miss. Miss, did I hear you?
No, I didn't hear you. So QR is the square root of the X value plus the Y value. And QR is the vector minus 6, 2. So work it out. Square the X, square the Y, and find the square root.
Yes, I get 10 and 1 squared is 3.16.
All right. That's somewhere. You got, what did you get for X squared, Nicole?
36.
Yes. So 36 plus how much? 2 squared is?
4.
Right. So you get the square root of 40. And what's the answer you said?
10.
6.32. Check by that. The square root of 40.
I got 6.32.
Yeah, miss.
All right. So
Make
see
out
what you
stick.
need to take down. Yeah. See what you need to take down there. And let's move to the other question. You ready?
Yeah, miss.
This is January 2020. I'll give it January 2021. Good afternoon, Nirmala. Okay, so this is the question. This is January 2021. They want a 2 by 2 matrix. Watch what it said. This is the matrix W. 3, 6, minus 2, 5. They want some matrix that will give this 0, 0, 0, 0. So what number, when we add to 3, we'll get 0. 3 minus what? 3 take away how much will give us 0?
Minus 3.
Minus 3. So fill in these values for me. 6 minus how much will give you 0? So fill in the spaces here for me. So what value would here be? The second value. 6 take away how much will give us 0? This will be minus 6. You have that? Right? This would be positive 2 because 2 minus 2 will give me 0. And this would be negative 5. You all get that?
Yeah, miss.
All right. We want a 2 by 2 matrix that will give us the identity. This is called the identity matrix. And a matrix W multiplied by 1 over W will give us 1. And this is the identity. So what they are asking you is to find the inverse, because this 1 over W is the inverse. So let's find the inverse. W is the matrix 3, 6, minus 2, 5. Let us find the determinant. So the determinant is when we cross opposite ends of the diagonal. And the inverse is 1 over the determinant. You're switching B and A, and you're taking negative of B and negative of C. So go ahead, work it out. All right, what do you have for the determinant? What did you all get for the determinant? 15 minus 2 by 6 will give us 15 minus 12, which is 27. Did you all get that? So this would be 1 over 27, 5, 3, negative 6, 2. Did you all put that?
Yeah, miss.
All right, let's continue. A right angle triangle has vertices 1, 1, 3, 1, 3, 4 when M is transformed by the matrix. So 0, 1, 1, 0, 1, 1, 3, 1, 3, 4. So this is a 2 by 2. This is a 2 by 3. The resultant matrix would be a 2 by 3. So row 1 by column 1. Work it out. Row 1 by column 1. Row 2, row 1 by column 2. Row 1 by column 3. Row 2, column 1. Row 2, column 2. Row 2, column 3. Try it. Multiply it and see what you get. For 2 marks. Tell me when you finish working it out, okay? All right, what do you all have? You finish?
Yeah, miss.
So the first thing is 0 by 1 plus 1 by 1. So I have 1. Do you all have that?
Yes, miss.
Then 0 by 3, which is 0, plus 1 by 1. This is 1,
Yeah, miss.
right? Then 0 by 3, which is 0, 1 by 4, which is 4. So my first row is 1, 1, 4. Did you all get that?
Yeah, miss.
Then we have 1 by 1 and 0 by 1. This is 1. Then 1 by 3 plus 0 by 1. This will give me 3. Plus 1 by 3, 0 by 3. So the vertices of x prime, 1, 1. The vertices of y prime, 1, 3. The vertices of z prime, 4, 3. Do you all see that?
Yeah, miss.
All right. So here's what, it's 4:51. Let's take a break until 5 o'clock. When we come back, we will continue with the paper 2 and we are going to the multiple choice. So we're taking a break for 10 minutes, right?
Okay.
All right. Are you all back?
Yes, Miss.
Yeah, miss.
Let's see. We may go a little bit over 6 o'clock today, like about 6:15, but I just want to ensure that you understand how to do these questions, as well as you can do the multiple choice, right? So bear with me a little bit today, as is our last class, okay?
Okay, miss.
The diagram below shows a triangle OPQ, which OP is 3U. So right away, this length here is U, 2U plus U will give us 3U. You all see that?
Yeah, Miss.
And OQ is V. So we have that. OQ is V. Right, we have that. Q is the midpoint of OR, right? And M is the midpoint of PQ. So we want to go from L to M. So if we are going from L to M, what two vectors must we add? What are the two vectors? To go from L to M, what two vectors we can add to go from L to M? We know the start vector must be L and we know the end vector must be M. So what two vectors?
L to P.
L to P. And here must be P to M. The vector in the middle here, this is the common vector and that must be the same. So we know LP is equal to U. We know that. We have to find PM now. We know M is the midpoint of PQ. So therefore, PM is a half the vector PQ. So we're going back because we don't know PQ. So to go from P to Q, we must go through point O, not so? Watch. We must go from P to O and then O to Q. You see that?
Yeah,
You all
miss.
see that? Right. So U plus a half PO plus OQ. So PO, we're going in the opposite direction. So PO is negative OP. And OP is 3U. So this is negative 3U. Negative 3U. And OQ is the vector V. So U plus minus 3 over 2U plus a half V. So if we have a whole and we take away, if we have a whole and we take away 3 over 2, we will get minus a half U plus a half V. Right? You all see that?
Yes, miss.
Yes, Miss.
All right, so take it out.
Finish, Miss.
All right. The next one now, we want to go from P to R. So we go in P to R. So therefore, P to R would be my vector PQ plus QR. You all see that? P to Q plus Q to R. To go from P to R. You see that?
Yeah, miss.
But we don't know the vector PQ, but we know the vector O. So here how we could pass. We could go from P to O and then from O to R because we know those vectors. So PR is the vector PO plus OR. The vector PO is minus 3U and the vector OR is 2V. So take that out. This is part B. You have that?
Yeah, Miss.
Yes, miss.
All right. So the next part, prove that points are collinear. So to prove collinearity, we need to find the following vectors. So we have the vector LM, and we need to find the vector LR. To prove collinearity, you show two things. You show that they have a common point. In this case, the common point will be M, and one vector is a scalar multiple of the other. So we worked out this part already here, LM. LM was the first part. That was minus a half U plus a half V. So now to prove collinearity, we need to find the vector LR. So we're going back to our diagram. We want to find the vector LR. So to go from LR, I can go from L to O and then O to R. You see that?
Yeah, Miss.
You see those two vectors, right? So LR is the vector LO plus OR. LO is negative 2U. Why negative? Because we go in the opposite direction. And OR is 2V plus 2V. So that is LR. So take it down. Let me scroll down. You have that?
Yeah, miss.
Right. So this vector is minus 2u plus 2v. So you see both vectors have u and they have v, and this one is negative, this one is negative. You can see that?
Yes, miss.
So here what we have to write. LR is a scalar multiple of LM, and L is a common point. Therefore, L, M, and R are collinear. So to prove collinearity, one vector is a scalar multiple of the other, and they have a common point.
Finish.
All right, let's go to the next one. Did you finish?
Yeah, miss.
So in these types of questions, you just need to do about 1 or 2 because it's almost the same thing they ask over and over again. So we're going to the 2019. No, we supposed to 2020 just 2020 paper, January. All right, this is the question. The question tells you the transformation M, which is OPQO, maps R to R prime. They are asking you for the matrix or P and Q. Now watch this. Write in your book for me the coordinates of R and the coordinates of R prime. Go ahead. Write in your book the coordinates of R and R prime. Tell me when I finish.
Finish, miss.
Right? So what are the coordinates of the point R? 2 minus 5, and what is R prime?
5 and 2.
5 and 2. So we have 2 minus 5 and 5 and 2. So 1, so we have to find 2 values. So when we have this matrix 0p q0 and we multiply it by 2 minus 5, we will get 5, 2. So watch this. one must be positive and one must be negative. Right? That is how it is. One of the values here must be positive and one must be negative. So let us see. So first row, first column. So 0 by 2 is 0. You see that? And P by -5 is minus 5P. Minus 5P is equal to 5. And Q by 2 and 0 by 5. And 2Q is equal to 2. So solve, take it down and solve for P and Q for me. Take it down and solve for P and Q. One value will be positive 1, while the other will be negative 1. Is the screen cut off?
Yeah, miss.
All right. What value you all have? For A and B. P is 5 over -5, which is -1. And Q is 2 divided by 2, which is 1. So P -1, Q 1. Did you all get that?
Yeah, miss.
All right. Bridget, did you get that as well?
Yeah, miss.
All right. They ask for describe the transformation. So this transformation, watch, it transforms this, or I should write it like this. It transforms this matrix. So we're not going in the form of a clock. We're going in an anti-clockwise direction at an angle of 90 degrees. So this is an anti-clockwise rotation of 90 degrees. So take it up. Right, you have that?
Yes, miss.
Yeah, miss.
What is one now? This is the vector part of the question. PQRS is a parallelogram in which PQ is U and PS is V. So we can identify that. U and V. M is the midpoint. M is the point such that QM is 1. So this is 1/3 because it's split into 3 parts. 1 and 2 will give you 3. And this is 2/3. So we can identify that. We want Q to S. So write for me the 2 vectors that will give you Q to S. Go ahead. Write the 2 vectors which you can add to give you QS. You want the 2 vectors which you can add to give you QS.
SQP plus PS.
You are correct, Nicole. QP plus PS. And QP, if PQ is a vector U, what would the vector QP be? It can't be the same thing. Sign must change. What would it be? Would it remain positive or would it change to negative?
We'll change the negative.
Yes. So this would be negative U plus V. You all understand that?
Yes, miss.
Right. All right. So let's continue. Right. The next part now, we want to go from Q to M. Q to M. So we can't go any direction for Q to M. We need to find QS. So QM is 1/3 QS. Why 1/3? Because it's split into 2. So this is 1/3 negative U plus V. So take that off.
Miss, how you already wanted?
Because watch how it is split here, Bridget. It's split into 3 pieces, 1 and 2. So here, therefore, this piece is 1/3 and this is 2/3.
Yeah, miss, I see it. I don't understand.
So I'm going to finish right there.
Yeah, miss, I finished it.
You going to finish?
Yeah, miss.
All right. Show that MR is 1/3 U plus V. So we're going from M to R. So MR, watch this, MR is MS plus SR. MR is the vector MS plus SR. Since this vector is traveling in the same direction as PQ, this vector would also be U. So this is 2/3 MS plus SR here. MR will go from MS, or we could go through Q. Let me go through Q, because we need to get 1/3. So we will go in this direction. We will go from M to Q and then Q to R. So work it out for me. MR is the vector MQ plus QR. So this is negative 1/3 of QS, which is minus U plus V plus V. So this will give us hello? Hello? Yeah, I went home. I will drop it for in the morning. Yeah, I will drop it early in the morning, right? All right, okay. Right. So watch this. 1/3 by minus 1/3 by minus U will give us 1/3 U minus 1/3 V plus V. So this will give us 1/3 U minus 2/3 V. And if we take 1/3 outside, we will get U plus 2V, which is what they asked us to show. So take it out and I will explain it a little bit in detail in a short while. Take it out. Can I finish?
Yes.
I want to show you all something. The question starts with 1/3. So that is why I went in the direction here. That is why if I have to travel from M to R, I didn't use MS because according to the answer, they want 1/3. So that is why I went from M to Q and then Q to R. Do you all see that?
Yes.
So the last part, P is the midpoint of PQ. T is the midpoint of PQ, right? So T had to be here, and they want you to show that they are collinear. So to prove collinearity, remember we have to show one is a scalar multiple of the other. So we're looking at two vectors, TR, and we're looking at MR. We already have MR, which is 1/3 U plus 2V. So we have to find the vector TR. So let's go here. We want to find the vector TR. So to find TR, we can add TQ plus QR. You see that? To go from T to R, we can go from T to Q and then Q to R. Do you see that?
Yeah, miss.
Yeah, miss.
Right. So QR is the same vector here. So this is V. And T is the midpoint. So therefore, this is a half U. So TR is really a half U plus V. You see that? Take it off. Do you all have that?
Yeah, miss.
All right. So TR is a half of U plus V. So here what we write it. This is important. We have to say that TR is a multiple of MR and R is a common point. So T, M, and R are collinear. All right, are you all finished?
Yeah, miss.
So
Yes.
once we do a couple questions on vectors and matrices, you're all supposed to be able to get the hang of it. There's a video on collinearity. I will get it and I will send it for you, right? All you need to know how to show the vectors are collinear, how to find the vectors in terms of the other variables, and to know how to multiply matrices. So those are some key points. There are 2 questions that I will send for you as well, for you to do for homework. But other than that, that's basically it for the vectors and matrices. So we want to try and do some of the multiple choice. All right, so this is taken from the July 2021. And the question reads, which of the following best describes the function? So if you notice, 2 is the input, 5 is the output. 5 is the input, 8 is the output. So to each x value, we add 3. Do you see that?
Yes, miss.
Yeah, miss.
So the answer is y is equal to x plus 3 because it's the y that is the output. So the answer is A. Y equal to x plus 3. The range for the domain. So x is mapped onto x cubed. So minus 2 cubed would be minus 2 by minus 2 by minus 2, which will give you minus 8. And D is the only answer that has minus 8. So that is our answer. 53, which transformation best describes PQR to P prime, Q prime, R prime? So if I draw a line here, this is a reflection. In which of the following polygons does the sum of the interior angles equal the sum of the exterior angles? Is it a triangle, a quadrilateral, or a pentagon? Let me check it. I believe it's I believe it's a quadrilateral because look at this. If we have a 4-sided figure here, and this angle here is 90 degrees. If this is a straight line, this also has to be 90 degrees. If this is at 90 degrees, the angle outside have to be 90. If this is 90, this angle on the outside must be 90. So the only answer there is a quadrilateral. What is the image of the line y equal to x when it is rotated in an anti-clockwise? Anti-clockwise, this will be y equal to negative x. The answer, D as in dog, y equal to negative x. This one comes regularly. A plus the translation will give us A prime. So 2, 5 plus some translation will give us 4, 6. So T is 4 minus 2, which is 2, and 6 minus 5, which is 1. So the translation is 2, 1. And that one comes in different forms, but it comes regularly. 57, we want BC. We want to find the opposite side. And we are given the hypotenuse. So the trig ratio that deals with opposite and hypotenuse is sine. So sine of 30 is BC over 40. So if you cross multiply, BC is 40 sine 30. The answer is A. What is the scale factor of the enlargement? Well, look at this. This is 1 unit. This is 2 units. So the scale factor is 2 over 1, which is 2. We take triangle ABC and we enlarge it 2 times to get A prime, B prime, C prime. We have a plane flying in the direction of 45 degrees and it changes in an anti-clockwise direction to 135. So here's 45 degrees and here's 135. The angle that it changes is 90 degrees, which is the difference between 95 and 45. And there was no question 60 for that one. Question 51 in January 2021. A line L is parallel. What is the gradient of the line? So I know it's a bit blurry, but nevertheless, 2x minus 5y minus 8 is equal to 0. So 2x minus 8 is equal to 5y. We divide both sides by 5. So y is 2/5 x minus 8 over 5. If the two lines are parallel, the gradient is the same. So the gradient is 2/5. Which of the following sets is represented by x squared plus 3? So if x is 0, 0 squared plus 3 will give us 3. If x is 1, 1 squared plus 3 will give us 4. So right away, this eliminates A and C. 2 squared plus 3 will give us 2 squared is 4 plus 3, 7. The answer is D as in dog. If A, B, C, O is that figure there inside the circle, and O is the center, there's a theorem that says the angle at the center is twice the angle at the circumference. So if here is 50, this angle here would be 100. In the diagram, PQ and RS are parallel. This is called alternate angles. When a transversal cuts 2 pairs of parallel lines, alternate angles are formed, and X is equal to Y. 55, a translation. So this one real blurry. We want to map WXYZ to W double prime X double prime Z double prime. So that's the way we map in this with this. So if you notice, it is smaller. So the scale factor needs to be, this is 4 units and this is 2. So the scale factor is a half because we map in WXYZ to W double prime X double prime Y double prime Z double prime. Right? It is not a reflection, so that is out. It is not counterclockwise. Anything that has to do with a rotation is out, because if you notice, the shape has maintained, the figure has maintained the shape. It is not twisted or it is not rotated. So anything that has rotation is out. This one has a rotation. So the answer that best describes it, it is a translation of 8 units to the left, followed by enlargement with scale factor of a half. Which of the following diagram shows a reflection in the x-axis? So a reflection in the x-axis is this one, because this is the object and the image will be the same distance behind the line. 57, they said that the triangle here is x and here is 2x. They asked for this angle. This would be 180 minus 3x. And the answer is A. 59, x, the angle here is 35, so here will be 35. Z-shape angles are alternate. YZ, this is the opposite, and this is the adjacent. So, opposite and adjacent, that is tan. Tan 35 is equal to YZ over 12. So, YZ is 12 tan 35. The answer, B. All right. So, this one was a repeat. We just did that. We could have eliminated this and this one, and the answer was this. This one we did just a while ago. It was 2/5, right? This one was 2/1. We just did that. P equal to Q. We did that one as well. A ship sailed 8 kilometers due east and then due north. So we're looking for east and then north. 8 and then 6. So the only answer is this. 8 due east, 6 due north. We want a reflection in the y-axis. So this is the object. The image would be here. The answer is B. This one we just did, right? This one, the scale factor, the answer is on here. The answer is 2, which is D. Number 59, we want the length MO. So if 6 divided by 2 will give me 3, 7 divided by 2, this will be 3.5. The answer, B. With trig ratio is 4/8. So this is the opposite and the hypotenuse. The trig ratio that deals with opposite and hypotenuse is sine. All right. A parking lot charges $1 plus 25 cents for every hour. So $1 plus 25 cents. So 25 each plus $1. Which of the following best describes the function y equal to x plus 3? If the sum of the interior angles is 4 right angles, it is a quadrilateral. Because think of a square and think of a rectangle. With trig ratio is equal to 4/8, we just did that. We have the opposite and hypotenuse, that is sine. 59. If 55, if this is 30 and this is 30, that is 60. So here would be 120. The answer, C. The transformation that has taken place. The transformation that has taken place. Well, this is an angle here, a 90-degree angle, and this has gone in a reverse direction. So it is an anti-clockwise rotation or rotation of minus 90 degrees about the origin. 57, we did that. The answer is B. 58, we did that just now. 59, 3.5, and well, 60 here. This is 30 degrees. This is the opposite side, and we have the adjacent. So tan 30 is YZ over 10. So YZ is 10 tan 30. The answer, A. So you all see how many questions are repeated? Are you all seeing? We did this one time and time again. The value of x for which y equal to 4x minus x squared intersects the y equal to 0, but that is the x-axis. It's 0 and 4. The coordinates of the turning point, 2, 4. This is the turning point. This is the point where the curve turns. Which of the following lines are perpendicular? Well, you have to work out the gradient of the pairs of the lines. So if you notice, this has 3 and this has -3. So this answer is wrong. This has 2 and 2. We're looking for the negative reciprocal, right? Look at this one. Y equals to minus 4x plus 10. Here, the gradient is negative 4. This is 4y is equal to x plus 1. If we divide each side by 4, y is equal to a quarter x plus a quarter. So this is the negative reciprocal. The answer is C. With transformation maps PQR to P prime, Q prime, and R prime. This is a reflection. 54, 120. We did that. This one, x equal to y. That is a repeat. This is 3.5. P is the coordinates 1, 2. P prime is -5, -4. We want the translation. So T is -5, -4, minus 1, 2. So here we will get -6, -6. The answer A. 57, 2, 59, 90, 60, A, right? So that brings us to the end of that multiple choice. So here's what I am going to do